Hey guys, welcome to Home Automation at Home. In this video series, I show you guys how to build your own home automation systems for just a fraction of the cost of the commercial systems out there. In previous episodes, I've been showing you guys how to build door sensors, temperature sensors, relays to control lights or fans or whatever you want in your house. So in today's video, I want to show you guys how to build one of these, which is an RGB mood lamp based off of the ESP8266. Now, in today's video, we're just going to look at how to wire this up, and we're going to go over the code that actually runs on this module. In later videos, I'm going to show you guys how to integrate it into Apple's Homekit so that you can control it straight from your phone. You can do whatever you want, change the saturation, and this lets you actually go ahead and integrate it into an existing HomeKit system. So I've found these to be really useful. I have about 4 or 5 of these throughout my house right now, and they work seamlessly with anything else that works with HomeKit. So in later videos, we're going to see how to integrate this into HomeKit, but for today, we're just going to take a look at how to wire it up as well as the code that runs on board. So the parts that you're going to need for this are a little battery clip here, a little JST 2-pin battery snap like for RC vehicles, an ESP8266 07 or 12 module, this is the 12 module, an LM1117 voltage regulator and a 100 microfarad capacitor, 3 NPN BJT transistors. These are 2N2222A transistors, although the other most common transistor, the 3904, will work as well. You'll also need 3 1K resistors, although honestly any resistor between about 220 ohms and 2K will work just fine. And lastly, you're going to need LED strip. Now this is non-addressable LED strip. This is just the whole strip lights up whatever color you make it. And so this is the 4-pin kind with 12 volts R, G, and B pins. And that's all you need. So to build this project, I'm going to build it freehand as I've done here, but you're welcome to also build it on a circuit board. I just really enjoy building freehand circuits. Sure, they can be more annoying sometimes and harder to debug, but there's something about it that I really love, the freehand dead bug style circuitry. So we're going to build it like this. So where I always start is on the transistors and the resistors here. So I'm going to move everything else out of the way, and we're just going to focus on these for right now. Now, if you're new to this kind of LED strip, it can be a little bit difficult to wire up, and I'm not going to go through all of the individual steps and how the transistors connect to the LED strip and which pins on the transistors. I'm just going to go through how to do it in this video. If you are curious and you haven't wired to this LED strip before, definitely go and check out my how to wire it video on this strip. It's really easy and it's a quick video, and it'll just make it more clear what I'm doing, because I'm not going to go and describe every little thing I'm doing. So definitely go ahead and check out that video. It'll help you understand exactly what I'm going to do here. Now, the transistors, what we need to do first off is, because this is the freehand circuit, I want to just connect the resistor here directly to the base of this transistor. So to do that, I'm going to splay these legs out here, and I'm going to cut that down this center pin, the base, just to a little bit right there, just so that it's a little tiny chunk sticking out there. I'm going to take one of my resistors, and I'm going to do the same thing. I'm going to cut it and leave maybe about 1/8 of an inch of wire there. And I'm going to line these two guys up on my duct tape here and solder them together. And there you have this creepy little bug looking thing. And this is one of the 3 transistors that we'll be wiring up. I'm just going to go ahead and quickly do the other 2. Alright, and here you can now see I have all 3 of my transistors all wired up with my 1K resistors connected to each of the bases. The next thing that I like to do is I like to wire up all of the emitters on these transistors. I just like to wire them all together into one so that all of the emitters are connected to each other before I even go and start attaching these to anything else. So the way I do that is on my duct tape here, I put one of them like that, and I make sure that whatever my next resistor is, it's in the same orientation, so I have the round sides on the right here. And I'm going to bend the emitter, which is, again, it's the left pin on these transistors, down like that, and place it right next to this transistor, so that the emitter is now crossing over and I have a nice little junction there where I can make a solder joint. Now I've got the emitters of 2 of these wired together. I'm going to do the last one now here. And I'm going to bend this one like that and put it on the other side. So now we have the center and left and right transistors. Like that. We have a little cross of pins here. And I'm going to solder that into the other 2. Just like that. And now we have this little pack of 3 transistors all neatly wired together with the 3 emitters all connected. The 3 bases have resistors on them, and the collectors will eventually wire up to our strip. So I'm now going to go ahead and clip all but the center emitter pin, the emitter pin on the center transistor. So I just have this one wire here that will connect to ground. So now we got these 3, and this one. Now we're going to go ahead and finally pull out our ESP8266 here. And the pins that we're going to use are pins 12, 14, and 16. So we're going to use these 3 pins will be our 3 pins that connect to our resistors here. So I'm going to go ahead, flip this right side up, and poke the resistors through those 3 holes for 14, 16, and 12. I got them neatly wired in there, and now I'm just going to splay them out and solder them in place. And we clip off the excess leads. And there we go. Our transistors are now connected to our board. Now we have this one last connection that we need to make from these transistors to our board here, and that's our emitters. And you have a couple choices here. You could just bend this and basically put it onto this shield here, and then put a big blob of solder and solder the emitter directly to the shield. I've found that that's just a very annoying way of doing it. It doesn't really work. It tends to break easily. Because this is such a big piece of metal, you really have to get the whole thing heated up before it will really adhere the solder. It's just kind of a pain. So instead, I'm going to bend all of these down over. And I have this little clip here connecting ground and GPIO 15. Which again, on the ESP12 and 07 modules, you have to ground GPIO 15 in order to boot correctly. So I have this little clip here, and I'm just going to bring my emitter almost so that it's touching it, and use a little tool here to maybe even pass that emitter pin underneath like that. And now it's just sticking out a little bit, just poking out a little bit from underneath that little wire clip that I made. And I'm just going to go ahead and solder that in place. Alright, there we go. So now our transistors are all three. All three of their emitters are connected to each other and wired onto ground. The 3 pins that we'll be using, 12, 14, and 16, are connected through the resistors to the bases of our transistors. And we have 3 pins left here. And these pins we are now going to solder and connect to our strip. So I'm going to clip them just a little bit shorter here. And whenever I'm working with this strip and I need to solder to it, I find the easiest way to go about it is to first basically lay down a couple of solder blobs onto these little copper pads here. So I'm going to go ahead and get a little bit of flux here and just basically paint on a little bit of flux. Make it easy for everything to adhere. And I'm just going to lay down 4 solder blobs, one onto each of these. And there we go. Now we got 4 quick, easy little blobs to work with. And I'm going to take my 3 pins here, my 3 collectors, and I am going to solder them to the R, G, and B pins here, leaving the 12 volt undone for now. And there you have it. Now we have our strip connected to our ESP module through our resistors, which will end up controlling the strip. And now all we really have left at this point is we need to power this. We need to power both the ESP module as well as the strip. So to do this, we're going to use an LM1117 regulator and our capacitor here and our little battery. So these regulators here, if you haven't seen my quick and dirty power supply for the ESP8266, these are really good. They're little 3.3 volt regulators and they support the full amperage of these guys. They do get a little bit hot. I will warn you guys, they do get a little bit hot. If you want, you are welcome to put a heat sink onto these. In fact, I more or less recommend it. I'm not going to do that for this video, but definitely if you have a long-term project, I would definitely heat sink this. So the pins on here are from left to right. We have ground, V out in the center, and V in on the right. So what I'm going to do is I'm first going to wire up this little capacitor onto this, and we'll move from there. Get some flux on these pins, make them nice and easy to solder to. And just like with the LED strip, I'm going to just basically put some solder blobs onto the legs of this regulator before I solder anything to it. So I've put the capacitor on the output side. So the positive is on the center pin here, the V out, and on ground. Oops, I actually didn't fully finish soldering that to ground. So now we have that neatly wired up in a nice compact little package there. And the next thing that I'm going to do is I'm going to solder in my power clip here. And I'm going to solder the ground to ground. So remember that ground is the same no matter what your circuit is. And the red wire I'm going to solder to the V in, this right hand side or the bottom pin in this frame. And there we go. Now we have my regulator all set up. We could put a 0.1 UF cap, 0.1 microfarad cap on this as well, but for this I'm just going to go with this 100 microfarad cap, and it's gonna filter it enough that this whole thing will be usable. So it's good enough for this project. So now we have our ESP module all wired up with our LED strip, and we have our power regulator here. And now we just need to attach these two together. Now, in the version that I've built already, I actually did all of this in a very tight, scrunched little area, and I actually did end up soldering the ground of this to the shield of the ESP here, and everything's really, really tightly together. Now, for the clarity of this video, I'm actually going to wire this using separate wires that connect to the ESP rather than showing this very, very tight, complicated little wiring scheme here. But it's basically the same, and if you want to wire it up like this, you're welcome to. It's just for clarity's sake, this is a little bit messy, even for me. Alright, so to get these two wired together with separate wires, I have 3 wires here. I have a red wire and an orange wire, and I have a black wire. So the red wire is going to be my 12 volt supply from the wall socket that I have, from the wall plug. The black is going to be ground, and the orange wire is going to be the 3.3 volts coming from the regulator itself. So I'm going to start off with the 12 volts actually, with the wire that will connect to the LED strip. So first I'm just going to get this connected to the strip by doing what I did before with the other wire, with the transistor pins, onto the 12 volt power right here. And there we go. Now this wire is connected to the 12 volts, and we can go ahead and wire it straight to our V in on our regulator here. Next wire I'm going to do is the black wire is ground, and that's going to connect to the other outer pin on the regulator. And there we go. Now we have ground connected. And we have just one last connection to make, and that's from the center pin on the regulator, the V out. And we want to connect that to the V in, the VCC, on our ESP module. So I'm going to take the last wire here and solder that to the VCC. So first I'm going to solder it to the regulator. And there we have that. And that finishes up all the wiring for our little RGB mood light here. So what we have is we have a regulator that will take 12 volts in here and regulates that down to 3.3 volts for our ESP module. And then we also keep the 12 volts and we connect that to our LED strip. And the LED strip is controlled via these 3 transistors here, connected to pins 12, 14, and 16 on the ESP. So let's go ahead now and take a look at the code that runs on these modules here. So here's the code that runs our new RGB light that we're building. And this code is much more extensive than anything we've looked at previously. So I'm going to try to go through it as quickly as possible, which means I might just go through some things without fully explaining them. If you have any questions, definitely ask me in the comments. I've also tried to comment the code as well as I can without being overly redundant in my comments. So bear with me. I might gloss over some things. If you're confused about anything, just let me know in the comments and I'm happy to clear it up for you. So to start off, we have our regular includes, our pub sub and our ESP8266 Wi-Fi. And then we have 2 new little libraries here. So the first one is a library that helps converting from hue, saturation, brightness values to RGB values. And since Homekit sends its values in HSB, we need to convert that to RGB in order to update our lights. And then we also have this MyTypes library, which I wrote. And all it is very simple. It's a couple of structs that just help eliminate writing variable names over and over. So we have a light state struct, which just handles holding anything for a given light command or currently where the lights are at. And then we have this timer struct here, which is basically for multitasking. So this program is non-blocking. When the lights are fading, it can still do other things. And so we have this little timer struct here to keep track of the last time we did something and how long we should take before we do the next thing. So you guys have seen these lines before. Just put in your server IP, your SSID, and your password. And then we have the pin definitions for our red, blue, and green pins. And we have a couple of enumerated values here. We have set and mood. So set is when we have a new value coming in from either Homekit or wherever that we want to set specifically to a new value, to a new color. And mood, which is our overall setting, our main mode for if we just want this to fade through the color wheel. We're not trying to set it to a light value or anything like that. We just want it to fade through the colors. And those colors are defined right here, red, green, and blue. LED mode, this is where we set whether we're fading or not, normal. So fading says the lights are currently in an action of fading, and normal is they're not fading, they're just static. And then we have, again, our different kinds of updates, which is an HSB, a hue, saturation, brightness command, regular, just RGB values, and then a power command, which is series Homekit. It's not very expandable, so in order to just set it to be a mood light or to be set to a specific color, we use the power state on and off command. So when we flip it and tell Homekit that the light is on, it actually says go and be like a mood light, just fade through the color wheel. And when it's set to power state of off, it's set to sending new commands. Light state, next state holds the next state that we intend to go to. So whether it's coming from Homekit or internally or whatever, next state is what we intend the next light to be, the next color. Our main mode is our overall mode, whether we're set or mood, and we initialize it to set. New command is basically a flag that tells us whether or not we have a new color command or not. Current millis just keeps track of the current time in milliseconds. The light topic, you guys have seen that. It's just what we're subscribed to. And then we have our timeout. And this timeout we'll use later on, and it basically will just automatically fail over to just being a mood light if there's no network in the area. So you can use this and build a light and then unplug it, take it somewhere, and plug it in. And after 10 seconds, it just fails over and becomes a mood light. So that's what this little timeout is for. You guys have seen this, connects to the server. So here's where I set the pins as outputs and turn them all off initially. And then I have a little color test function, which is down here. It's basically just a little self-test to make sure everything is working correctly. Turn on the serial, start up the Wi-Fi, try to connect to the network. You guys have seen that. And in here, in loop, we make sure we're connected to our Wi-Fi. And this is where that timeout comes into play. So we basically say, if we're not connected to Wi-Fi, increment timeout. And once timeout equals 5,000, and because we're delaying by 2 each time, that 5,000 really means 10 seconds. If the timeout is equal to 5,000, we just set our main mode to mood, set our fade period to 5,000, which is basically the time it takes to fade from one color to the other, and tell it that we have a new command. So, and then we reset timeout. So this is where we just fail over to being a mood light if there's no Wi-Fi to connect to. Run our client loop, keep track of the current time. This will be used later on. And then we run our light handler. So light handler is the sort of main function to deal with anything light related. So when we get new commands, this is called, and it, it does everything required to set up for new commands and also just keep track of the lights. So at the top we have two light states, one for new state or whatever our next state would be, and our current state, which is the current settings for each of the lights, the current brightnesses and fade speeds and so on. The current mood color and is fading, these two basically keep track of whether or not we are currently fading and what color we're currently on, if the main mode is set to mood. So if it's set to mood and we're not fading and the current color mode is equal to red, that means that the last time this was run, it was set to red. That means that we don't want it to be red anymore. We want to go from red to green. So we set green to be the maximum brightness value. On the ESP, we don't use 0 to 255 for PWM. It's 0 to 1023. So we go to 1023, and the others should be 0. We tell it that our next update type is RGB, and we flag that we have a new command, and we set the current mood color to green. So the next time we come to this chunk here, and we go to blue, and then we set it to red, change that to red, and we come back up here back to red. So that's how we change between our different mood light commands. And the next thing we do after we've checked to see whether we're running a mood light or not and set the new command for that if we are doing a mood light is we go to light updater. And light updater does a whole bunch of basically calculations to determine the difference between brightnesses and the speed and all of that. So that's down here. So here we have our light updater, and this takes in a new state and a current state. And the first thing it does is asks whether we have a new command. If we do, we run the calculations for either being an HSB or RGB command. So if it's an HSB command, we convert the HSB to RGB, and then we figure out the difference between the current brightness and the new brightness for each LED, and then we basically calculate how long it will take to fade from the current brightness to the new brightness. So we do a little bit of math here, and we also have to divide by 0, unfortunately, so we do a little bit of math and prevent us from dividing by 0. And then we set the new fade period. So all this math was to basically calculate if we want to fade 20 values in 2 seconds, we need to increment or decrement by 1 every 100 milliseconds. So that's what all this math was, and it's related directly to fade period. So our fade period is usually 1050 cycles, which turns out to be 2100 milliseconds because each cycle takes 2 milliseconds. So just a little bit of math to figure that out. And it's the same math down here, but adjusted for taking an RGB command. So then finally we come up to light changer, and that's what we call after we call light updater, we call light changer. And light changer is actually where we set the new LED values. So this is where that little timer that I had comes into play, because we want to change once every 2 milliseconds, but we don't want to stop everything else from happening. We want to be able to change a value, leave this all together, and come back to it when we need to change another value. So I have this function that's called check timer, and it takes the previous time and our interval and does some math to calculate whether or not it's time to run again. So down here we have check timer. It's all the way at the bottom of the program. And check timer goes and takes the previous time and the interval and checks whether the current time, the current millis, minus the previous millis, the previous time, is more than or equal to interval. If it is, set the previous time to current time and return true. Otherwise, return false. And this here is basically a compacted version of the code that can be found under Sketchbook, under File, Examples, Basics, and Digital. Blink without delay. It's basically a compacted version of that. So if you're wondering how this works and you're kind of confused, go check out that example and it will explain it out a lot better. So inside Light Changer, we've created our timer here, and that's what we use in this check timer. And we have a change mode, which is either normal or fading. We initialize it to normal, and a current period. And this keeps track of the current number of cycles we've had, and we can compare it later on to the fade period. So the number of cycles it should take in total to fade from one color to the next. So we check to see whether we have a new command. If we do, we set new command to false and we set it to fading. Because if we have a new command, we are automatically going to be starting to fade. So if our mode is set to fading, we check basically our light states, our current states, against our new states for each color, so red, blue, and green. And if these are not equal to each other, then we run this code. We also run this code as long as the current period is less than the fade period. So if we haven't been fading for a total of 1050 cycles, we keep running this here. So if we are fading and our lights are not set to the correct values quite yet, we then run the code in here. And all this does is has 3 if statements. It basically makes it so that colors change nice and smooth. So we do that for each of the 3 colors, and we have an if statement that asks whether or not we basically need to fade up or down. And then we write those values out to our pins. And then after that, we just increment current period and return true. Because if we're fading, we return true. Otherwise, so if this here has failed, so all of the light states are set equal to what they should be, and our current period is equal to or more than our fade period, we come here and we reset our current period, we change our mode back to normal, back to not fading, and we return false. And we also return false here if our change mode was not equal to fading. If it was equal to normal and we skipped all of this code, we also return false. So that's basically all the code that has to do with handling the lights. Now there's a little bit more code. Just bear with me here. We have our callback. So this is our Mqtt callback. So this is where when we tell Homekit that we have a new command, that we're setting something new, and it goes through and gets to the Mqtt server, we will receive a new command on our callback, and that will hit this function here, our callback function here. And in here, the first thing we do is we create a new payload, a new character array payload. And this is just to fix a little glitch in the Mqtt function here, in which this payload is not null terminated. So we basically just create a new payload and null terminate it. And the basic setup for each of these commands is that we have a 1 byte, a 1 character header, which tells it what kind of update this is. And then we have our values. In general, they're comma separated and 3 values: hue, saturation, brightness, or red, green, blue.
The one that isn't like that is our power command. So this is where we either hit the power button and set it to mood light or hit the power button and set it to regular. This just has a P for its header and then either a 1 or a 0. But normally the commands are generally going to be HSB or RGB. And so we have an H or an R denoting HSB or RGB. And when we get an HSB command, we set our next state hue to the payload, to the first comma separated part of the payload. The second part is the saturation, and the third is the brightness. And then we tell it that we have our next state is its update type is HSB. Our fade period is 1050. And our new command is true. So this just flags and tells us, hey, we have a new command, so go and do all the math and do everything that you need to do to set the lights to that. And we tell it that our mode is set. It's not a mood light, it's just we're setting it to a specific value. And it's basically the same for RGB as well. We grab the values and we convert them from strings into actual values, into numbers. And we set those red, green, and blues to that. And then we tell it that our update type is RGB, not HSB. Same fade period. Again, flag that we have a new command and tell it that our mode is set. Power is a little bit different. It basically is just a P1 or P0. If it's a 1, we set the mode to mood, so this sets it to a mood light. We tell it that our fade period is 5,000, which should be about 10 seconds. And we flag that we have a new command. If we have a payload of 0, a P0, that's setting our power state to off in Homekit. And that just says that our main mode is equal to set and changes our fade period back to 1050. And again, flags that we have a new command. So power is pretty simple. So yeah, that's, it is a lot more complicated than anything I've shown you guys yet. If you guys have questions, let me know, definitely. I know this is a lot of code to go through and that I probably have skipped over some things that may be really confusing or didn't explain things very well. I totally admit to that. If you guys do have any questions, definitely just let me know in the comments. I try to keep up with the comments. I want to hear what you guys have to say, and if you have questions, I want to answer them.
All right, well, I think that's about all that I can pack into this video. In the next episode, we'll be looking at how to integrate this light into our existing system and into Siri's HomeKit. So definitely stay tuned for that. Keep an eye out. And if you guys like this video, definitely give it a thumbs up and also subscribe to my channel. You can also find me at ItKindaWorks.com and on my Twitter at ItKindaWorks Inc. All right, well, that's all for now. I'll see you guys later.